Hey everybody, it's Miss Falkenberg. I am here to kind of close up uh, section 3.7 and just finish going through my slides. I know the book online resources is going to be awesome, but just in case, I wanted to go through my slides and examples to see if it'll help finish your homework. Talked about three equations. First equation being slope-intercept. That's the most familiar, I believe, and it's also the most helpful to visualize lines. Second was standard form, and we saw a trick if the constant had the factors as coefficients, you could plot it really cool with a slope, like setting x equal to 0 or y equal to 0, so finding the x and y intercepts. The last equation is the point slope form, and it is awesome because you can write equations if you know the slope of the line and a point, or if you just know 2 points, because then you can find the slope. So, all right, let me start going through the examples and see if this is going to help. So I've got an equation of a line through point P, 2, 4, or 2, -4, and slope of a -1. So if I write down my point slope form, y minus y1 equals the slope times x minus x1. This is my x of 1, this is my y of 1, and I'll plug it in. Y minus a -4. I'm putting parentheses. This is one of the larger areas of an error. If you subtract a negative, you got to keep track of it. The slope of a -1 and an x minus 2. Okay? So the y minus the -4 will just be y plus 4. So I'll just go through and simplify this. This -1 times everything in the group is just going to, or parentheses, is going to change the sign for everything in there. So -1 times x is -x. -1 times -2 is +2. I'll subtract 4 from both sides, and I'll get y equals a -x minus 2. Now, I love slope-intercept form because I can quick do a graph that hits at -2, and then it's a negative slope of 1/1. That's the gist of the line on the x, y coordinate plane. Okay. So you can write an equation, right? Start with point slope form, finish by simplifying. Now next, we are going to do writing equation line through 2 points. Now we're able to do this because we can find the slope, and I'm hoping this is previous information, but if it's not, it should be in the book as far as slope formula. y2 minus y1 over x2 minus x1. That is the rise over 1. Overrun is what I meant. So when I plug it in, I can do my y sub 2, we'll call it a -1, and I'm going to subtract y sub 1, which I'll choose as 3. Okay, since I went -1 on this side, this is my x sub 2, 1, and I'm going to subtract a -2. That will give me -4, right, over 3. So that is my slope for this line, -4 over 3. Now, I'm going to take that slope, and I'm going to choose either point, okay? Sometimes I strategize which point would be the best, sometimes when they've got a 0 in it, but I'll just do it for A, and maybe you can do it for point B. I plug it into my point slope form. So y minus 3 equals a -4/3. X minus a -2. From there, I will simplify by multiplying the -4/3 through. That becomes a +2, so a -8/3 and y minus 3. I'll add 3 to both sides. 3 in thirds is 9/3. So y equals a -4/3 x. And looks like +1/3. Now that's got a lot of fractions in it, but if I were doing a quick graph, I'd hit at a just above the x-axis, and I'd be at a slope of -4/3. So that's a rough estimate of that line. Now, what I would challenge you to do is with that slope, confirming that you can calculate the -4/3, use point B and see if you end up with the same line. The last concept is working with horizontal and vertical lines. Not really knowing which one has a slope of 0 or a slope that is undefined, sometimes it can help us think about it this way. When a slope is 0, there's no resistance up or down, positive or negative. You're just walking along a horizontal line. I would say that's the slope of 0. But when you've got a vertical line, that is undefined slope. You're walking along and boom, you're just hitting a wall. So, but when you're graphing the following, right? I've got y equals a -1 and x equals 5, and those are two separate lines I want to graph. This is my way of going about it. When I see y equals 1, that says for every point or coordinate pair, I'm going to have the y value equal a -1. So then you can pick 3 numbers for the x values and make them easy. 0, 2, 4 maybe, right? So when I graph, and I'll do it in red, y equals -1, if I go 0, -1, and then I go 2, -1, and I go 4, -1, you get the trend that this y equals a -1 is a horizontal line that hits the y-axis at -1. Okay? So if I do the same thing in green for the x values, x is going to be 5. Right? Now, it's likely you already know it's going to be a vertical line, but we'll just test it, right? 0, 2, 4, 5, 0, 5, 2, 5, 4 has a vertical trend. X equals 5. So you can see it's kind of counterintuitive. You think the x would be a horizontal line, but it's not. It's a vertical line. But you could think of it as going through the x-axis at 5, and vice versa. When the y equals a -1, it's going through the y-axis at a -1. But I think it's a pretty rock-solid way to determine if it's horizontal or vertical by recognizing that if x equals 5, that it will be 5 in every coordinate pair. Plot 3 of them, and you've got the trend. Actually, you only need to plot 2, but it's nice to see the pattern. I hope this helps you in your homework. I hope you have a great 3-day weekend, because those are awesome. And I look forward to seeing you on Monday. All right, see ya.